Hey, hi, I'm Ramya, embedded software engineer at Microsoft Technologies. Welcome to the motion detection system with TDCA. So, in this video, we will showcase a motion detection system that uses TDCA to detect movement through a PIR sensor and triggers a servo motor to open a door automatically. We will walk you through how the system integrates both virtual simulation and physical devices for real-time control and monitoring. So let's see what is TDCA. TDCA is which means Target Device Communication Interface that bridges a simulated RTOS with a real hardware. So like Arduino, what we are using here. This setup allows the host machine to interact with and to control the hardware in real time, making it ideal for testing, debugging, and fine-tuning embedded systems. So let's see the overview of the project. This project uses an Arduino with a PIR sensor to detect motion. When motion is detected, the TDCA enables the simulated environment to control real hardware in real time, allowing the system to open a door using a servo motor. The main objective is to create a reliable, responsive motion detection system that uses TDCA framework for effective security and automation. So let's see what are the components we are using here. The system consists of a PIR sensor and a target Arduino board and servo motor for door open and close purpose. So with TTCA, developers can simulate and control the motion detection system in real time, creating scenarios like automatic door opening whenever motion is detected, which is controlled by an auto simulation. So, the motion detection logic, such as opening the door when motion is detected, is developed and tested within an ARTA simulation on the host machine. TDCA lets developers simulate system responses like door open close, allowing them to optimize behavior before running it on actual hardware. Here, a USB serial connection links the host system to the Arduino. So through TDCI, the host sending commands to the Arduino when PIR sensor detects motion, simulating real-time door control. The PIR sensor feedback also flows back to the host and enabling a continuous adjustments. So, using TDCA, developers can create testing environment to simulate different motion detection scenarios. Um, for example, when PIR sensor detects motion, TDCA sends command to rotate the servo motor, opening the door in real time. TDCA lets developers monitor and adjust the system as it runs. For instance, they can dynamically adjust how long the doors stay open or control the sensitivity of the PIR sensor. Feedback like the current status of the door and sensor is available in real time, allowing quick adjustments for optimal performance. So now we're going to see the example overflow. First, the host simulates the motion detection logic within the RTOS, setting condition like when and how long the door stays open after the motion detection. Through TDCI, host sends command to Arduino to activate the servo motor, opening the door when PIR sensor detects movement. The Arduino responds to the host commands, rotating the servo to open the door when the PIR detects motion. After a delay, the servo returns to the closed position. The Arduino sends real-time data back to the host, confirming motion detection and door status. This feedback allows the RTOS to verify system performance, allowing further adjustments as needed. So this is how this project is using these components to handle the sensor conditions with door open close. So now let's see the coding part. Coming to this coding part, as usual, you should include this TDCA.h, which is necessary to use TDCA API call, and inside this OS application start function call, you should initialize the TDCA init with your COM port number, and then as follows the Arduino code for the motion detection system. So now I'm trying to run this code, right click open with system editor. So now you can see that my code is started running. Here I can show you for each command. I'll show you clearly. For each command, I'm getting the response from the target port. So I for a pin mode, and I'm so from this console output, you can see the success status of the each API, and then I'm getting a sensor value either 1 or 0 based on the motion detection. So when it is 1, there is no detection happening. When it was 0, then motion detection happens, so that my servo motor is start running. So this is servo motor direction. It is rotating from 0 degree to 250 degrees. So that is what it is rotating, which means the gate is opening. So when again, if there is no motion detection, then my param value should be 1, and my servo motor is turned off, that is indicating 0. Similarly, when I'm trying to detect the motion sensor, you can see when it will be 0, then again my servo motor will start running from the direction of 0 to 250. So this is how, when the motion is detecting, we can control the door automatically by open and close. This is how we are using this motion detection system to automatically close and open. So for door purpose, I am using the servo motor. Now let's see the hardware setup now. This is my hardware setup for my motion detection system. So this is my Arduino Uno board and PAR sensor and then servo motor. So I gave all the required connection to my Arduino Uno board. So now I'm going to start running this project. So initially PAR sensor is not detecting anything, so that my servo motor is not turning on. So when I'm trying to detect the sensor, then my servo motor is start running, which means when motion is captured nearby the door, then the door is automatically open and close. So now I'm going to detect the sensor. So when I'm trying to detect the sensor, my servo motor is start running. So this is like just opening the gate. So however I'm detecting the sensor, that much time my servo motor is keep on rotating from 0 degree to 250 degree. So using this motion sensor, we can open the door or close the door using this servo motor. So with TDCA, developers can simulate, control and optimize a motion detection system using this PAR sensor and a servo motor. The combination of virtual and physical systems streamline the PAR sensor development and enabling a seamless real-time testing and quick adjustments for a robust responsive motion detection door control system. So this is how we can achieve a motion detection automatic open and close door using this RTOS based TDCI mechanism. I hope this project helps to you. So that's it. Thanks for tuning in. If you found this helpful, stay connected for more artist related videos. Bye.